Good afternoon, everyone. Can you hear me? All right. Uh, Welcome. I am Jeff Downing, Executive Director at Mount Cuba Center. Mount Cuba Center is a botanical garden in northern Delaware. It's about 30 miles southwest of uh, Philadelphia. Um, Mount Cuba is a native plant-oriented botanic garden that was started by a family called the Copeland family. They built a house on a fallow cornfield in 1935, and they lived there their entire life with their family. And it became a family foundation. And they had wanted their garden to be a public garden since at least the 1960s. But over time, they became more and more interested in native plants and in conservation as they saw development encroaching around their property and things like that. They're a branch of the DuPont family. Mr. Copeland was actually the last member of the DuPont family to run the DuPont company. Is that showing up okay? No, it's not. That's interesting. Anyway, so this afternoon we're going to be talking about nature-based solutions, and this is going to be kind of a moderated discussion. So I'm going to do 15 minutes of talking. Christy's going to do about 15, 20 minutes of talking, and then the rest of the time will just be kind of like a moderated discussion on topics around nature-based solutions. Today, I'm going to be talking about a couple of plant trials that we do. One of the things that Mount Cuba Center is known for among people who actually know of us is that we do plant trials of native plants in our trial garden. We have about a 5,000 square foot trial garden where we trial a number of different native plants over the course of 3 to 4 years, sometimes even longer than that. Over the time that we have been doing these trials, which started in around 2002, we've completed something like 13 trials listed here. One of them or two of them we've done twice now. And then we have a number of other trials that are currently in process. And I'm going to talk about two of those. Now, Mount Cuba Center only opened to the public in 2013. Before that, we were kind of a private foundation. It was a house until 2001. The Copelands were very long-lived. Mrs. Copeland lived into her mid-90s and passed away in 2001. By the time she passed away, a foundation had been created, a board had been established, and everything was in place for Mount Cuba to become a nonprofit public garden upon her passing. After she passed away in 2001, very little happened. There were 2 tours a week at Mount Cuba Center, and the only other thing of particular note that was happening is that they began trialing some native plants. And they went relatively unnoticed for quite a while. But over time, we built the new trial garden and we started kind of promoting it. We opened to the public for general admission visitation in 2013. So we've only really been open as a public garden for about 12 years now. But as it happened, as we started developing and publishing these reports, a very fortuitous thing happened. And that was that we were completing these reports after 3 or 4 growing seasons. It would take 3 to 4 months for our trial garden team to put together all the information, and they would get published around December or possibly like early January. That was incredibly fortuitous because there were at the time still a few gardening columnists that were syndicated, Adrian Higgins and a couple of others. And in January and February, they were desperate for something to talk about, to write about gardening. So when our trial garden report started coming out in December and January, they found that to be a compelling thing to be able to write about in January. As a result, more and more people started to notice our reports. At the same time, more and more people were getting interested in native plants as a form of gardening. And it all started to come to a head a little bit in 2023 when we published a report on carex. We had a carex trial for 3 or 4 years in our trial garden, little grasses. We didn't think it was going to be that compelling of a trial personally. And what ended up happening is when the trial was published, Adrian Higgins wanted to write about it. The New York Times wanted to write about it. Next thing you know, all these bloggers were writing about carex. I just put on this slide, I did a little Google Trends analysis, and the highest amount of Google searches that included the word carex in the past 20 years was in May 2023, about 4 months after we published this report. So people were paying attention to our trials at this point. The other thing that we saw that happen that was notable that the nurseries let us know was that these plants started flying off the shelves, because essentially it's like consumer reports for plants. And so, the highest performing carex out of our carex study was this little bitty plant called Carex woodii, and the local nursery guys in the wholesale trade were saying, like, this is a plant that sat on our shelves for decades with very little interest. Everybody was planting Carex pennsylvanica as like the big one, but then all of a sudden we published this little report out of this little garden where we are, and all the Carex woodii flew off the shelves. One nursery said that they sold out of all their Carex woodii for the year in just the first day that the report came out, which was really it was validating for us. But it meant we had to think differently now about how we think about these trials and our relationship to the producers. And that really came into play with an upcoming report that's about to be published this coming winter, and that was is going to be on solidagos, or goldenrods. And for the goldenrod trial, we trialed something like 40 different selections of goldenrods. When we do these trials, we try to get all the selected cultivars that we can find, but then we also like to go and collect some wild collected straight species and plant those next to the selected cultivars so that we have a comparison. And that was all well and good until we got to this solidago trial, where the things that started to come out on top in the overall trial were these wild collected wild types. But this turned out to be problematic because we had collected these things from a field in northern Delaware in some cases, and they were just not available in the trade. And when we realized that the things that we were going to be recommending were going to be things that people were not going to be able to go and get, we were like, well, that's not going to work. The whole point of these trials is to help connect people with the plants that are going to perform well in their gardens. So, in fact, what we ended up doing is we've delayed publication of this report for now 2 years. This report was actually completed 2 years ago, but what we did is in the past 2 years we had to go back to all of these little kind of locations where we found these wild type straight species, recollect them, and then we had to talk to the wholesale nurseries that we work with and get the seeds, and in some cases cuttings, into their hands so that they could start growing these things out for commercial distribution. So that's happened, and it's so now by next spring, now they're going to have a couple of these ready, which is going to be really helpful because, as it turns out, you can see on the slide, actually half of the things that came out as the highest performers in our trial are things that were wild type species. Now, the things that we look for or study when we're doing these trials are everything from the bloom, how many flowers, how beautiful are the flowers, the habit of the plant, does it stand up, does it flop over, disease resistance, pest resistance, things like that. We also have a group of volunteers that is trained to collect data on how many pollinators visit each of the different selections of plant. And so by the time we get done with the 3 or 4 years of these plant trials, we can tell people not only which ones perform best horticulturally, but also which ones are going to be the best food sources for pollinators. And when you put those things together, you can really find what are some high-performing plants. So what are some high-performing plants? With solidago, one of the ones that came out at the very top of our trial was a plant called Solidago gigantea. The material for this plant is one of the ones that was collected not too far away from Mount Cuba Center in a field in northern Delaware. It's a rhizomatous plant, 6 to 7 feet tall, with an upright habit, nice floral display, and it blooms July to August. It's a nice plant. You can see we got that plant, we recollected from these plants and got them out to some nurseries. This is one of the ones that's growing the plant. You can see it early in the season, the little plants, and then closer to harvest time out in the back. Now, one of the other great things that now that some of the straight species are doing really well in our trials is that they are suitable not just for home gardens, but they're also things that can be used in seed mixes for conservation. Because since they're wild species, they're not genetically clones. They have the genetic diversity in the populations that allow them to be used for conservation. So not only are we growing plants with the wholesale nurseries for garden centers, but we're also collecting seeds off of them for potential additions into new seed mixes. Another plant that we're doing that with is another solidago called Solidago fistulosa, pine barrens goldenrod. This material was also collected in Delaware, in southern Delaware, which is coastal plain, whereas northern Delaware tends to be Piedmont. It has an excellent habit. It's disease resistant. It's got good floral display and nice fall color. It blooms a little later than the Gigantea. It blooms September to early October. But it's as you can see, it's another beautiful plant. And this one is also in production, and they're growing it as plugs, and they're also growing it to collect seed. And as I said, this is a wonderful thing because it allows us to get new species that are currently not available into production for both gardens and also for conservation. And so this is what it looks like out in a conservation setting. But we also at Mount Cuba, we do lots of other kinds of research that I don't have enough time to talk about today. And one of those research programs that we have is that we've been developing pollinator meadows. These are intentionally planted meadows. Mount Cuba Center has about 1,100 acres overall. About 100 acres of it is part of where our kind of visitable gardens. And then we have trails that allow visitors to visit some of the additional 1,000 acres of natural areas that we maintain and manage. And in some of those areas, we decided that we wanted to try some new strategies to plant for pollinators. And so we took out what had been like cool season grasses and things like that, traditional kind of hayfield mixes. And we sought to get as many different species of seed for these pollinator meadows as we could get. We sought out originally trying to get our natural lands manager was looking for 100 different species that he had identified as locally occurring and would be beneficial for pollinators, but he couldn't find 100. When we searched all the providers that we could get seeds from, and it turned out we were only able to get 38 or about 40 species of these seeds. And that is consistent with a general theme in the conservation world, which is that there's not enough native seed out there to be able to accomplish all the conservation projects that our conservation practitioners are looking to accomplish. And there was a big study on this that came out a couple of years ago. This is the cover of it. It was done by the National Academies. An assessment of native seed needs and the capacity for their supply. And they asked lots of the conservation practitioners in the United States, are you able to find all of the native seed that you want for your conservation projects? And just about to a person, they all said, no, we can't get all the seed that we want for our conservation projects. But again, these are conservation practitioners, so their ambition is really high. Like our natural lands manager who said, I want 100 different species to put in this pollinator meadow, but that's not really findable. When we couldn't find all the seed we wanted, we got all of the local nursery guys together, guys and girls, women, people, and had a focus group and said, we're looking for, to get the broadest kind of amount of native seed available. Can you help us? We wanted to get 100 species, and we were only able to get 38. And they just looked at us deadpan and said, yeah, you want 100 species, but there's just not that many practitioners out there that want the locally adapted specific seed that's localized to the Mid-Atlantic region that you guys want. There's just not enough people out there to make a market. In fact, when you ask the practitioners how do they deal with this, they say that when I can't get the kind of seed that I'm looking for in a project, often what they'll do is they'll go and they'll substitute for a different species that they can get that's also locally adapted, but will just fill that gap in their seed mix. But sometimes what they'll do is they'll just adjust their proximity requirement and say, well, if I can't get the locally adapted seed that comes from within 100 miles, I'll get the seed from Ernst, is a big provider not too far from here, I think, that just will provide more generalized mixes that in some cases don't necessarily have that locality baked in. And that's just what people do. When you ask the conservation people, about 30% of them say that they frequently will just like, if I can't get the local stuff, I'll just get some other stuff, but it'll be the same species, just not from around here. Another 60% say that they would sometimes do that, even if they don't prefer it. But the question really gets down to, when does local matter? And it's certainly the case. And I'm not a botanist. I'm not a horticulturist. I'm nothing. I got a bachelor's degree in economics, and I went to divinity school. So I know nothing about what I'm talking about right now. But it begs the question, like, when does it matter? And as I understand, and there are certainly cases where it's been demonstrated that, like, if you don't have locally adapted material, that it won't behave in the ways, it'll behave differently, and it won't perform as well. It won't bloom at the right time, and bad things will happen. That said, there are also surely a number of cases where the non-local seed is probably fine. As we saw, the actual practitioners, they're doing it all the time. And I rarely hear from somebody who's a conservation practitioner. It's like, yeah, I planted all this stuff, and because it wasn't local, it all just died. You don't hear that very often. Sometimes it happens, but most of the time it doesn't. So the question is, like, when does it matter? So our trial garden team decided that they wanted to start to investigate this question a little bit. And the way they're doing it is with blue stems. We have just started a blue stem trial that includes 40 species of big blue stem and 30 species of little blue stem, both species and cultivars. Like all of our plant trials are going to be evaluated for their beauty, their adaptability to average garden conditions. And this trial is going to go for about 4 years, and it'll be published in 2029 or the beginning of 2030. In this trial, just to see how geography matters, we have selections that came from New Jersey, selections from northern Delaware, southern Delaware, some from Virginia, Alabama, and even Missouri. And we're going to be studying these over the course of this 4 or 5 year period just to see how different they are. And the goal, in part, is to see if locality is less important with some of these species. Maybe we can help relax our self-imposed geographic restrictions to such locally adapted material and be able to use a broader set of things. Like I said, I'm not a horticulturist or a botanist, but I did get a degree in economics. And when I look at this thing, what I see is a market problem. That, if you have all these land managers that want these very specialized crops, they're going to be very expensive and they're going to take a long time. If there are certain cases, and I think there might be some, where the locality isn't quite as important, then we could just say, like, oh, with little blue stem, you can just go to Ernst and just get their generalized, generic little blue stem mixture, and it's probably going to perform just fine. And so we're trying to kind of break down some of those barriers. However, I know from talking to some of our own conservation staff that can be a really explosive conversation. Because this notion that, like, locally adapted is always critical has been really, really hardwired into a lot of our land managers' kind of orientation to conservation. So the conclusion is just that sometimes species that are less ecotypically sensitive can be mass produced for a wider distribution. And so we're trying to start the process of trying to evaluate when that's the case. In short, the other way to say it is, like, when should we be allowed to break the rules as far as conservation goes? And that's my little introduction. So with that, I'm going to pass it over to Christy.
All right. Hopefully everybody is doing all right. I think there's still some coffee over there if you need your post-lunch pick-me-up. My name is Christy Rollinson. I am a senior scientist in forest ecology at the Morton Arboretum. So I am approaching this kind of from the lens as a scientist. I promise I try not to kill you with numbers and graphs, but I had to sneak one or two in. And so I'm kind of approaching this from a different angle as Jeff. A lot of my work, we've been taught to generalize. So I actually won't be telling a case study about the Morton Arboretum, but hopefully giving you some high-level perspectives that can prompt some good discussion here in a few minutes. And so really thinking about kind of opportunities, limitations, and considerations of trees as a nature-based solution, specifically for urban heat. Because anytime we're talking about a solution, it's for what? There is no silver bullet to the world's problems. Good Lord, I wish there was. And as much as I love trees, it's not trees. But I'm also approaching this from the perspective of when I think about nature-based solutions and climate change, my first thought is, how does climate change impact the nature part? And so that's one of the big things as we're thinking about designing nature-based solutions for whatever challenges you choose. It's having to take into account that both nature and the climate system are dynamic. And so what we're doing now, we need to make sure that we are making decisions that are the best they can be for the future, but we're also prepared to change track as we go because the future is very uncertain. Also want to acknowledge that anything I'm talking about is not just me. Science is not the crazy old white man in a lab coat. That's just not how it works. So there's a huge number of people and a number of people that I meant to put on there, like Jessica and some others, because just like anything else, science and approaching solutions to climate change requires collaborative interdisciplinary work. So trees, yeah, trees provide many benefits. And I think that's something probably even y'all non-tree people have heard. And again, the idea is that there are all of these co-benefits, but if we're trying to optimize a solution for one thing, you know, the classic master of all trades, wait, no, that's not right. Jack of all trades, master of none. There's a lot of uncertainty in all of these. We know that trees are great for mental health, stress, stormwater management. As a scientist, I'm used to like, well, what about this and like a lot of these things there's evidence for it, but actually a lot of those things are not necessarily well quantified. And some of those links are perhaps a little wishy-washy. They're there, they just need more research and understanding. However, one of the benefits of trees that has probably the most robust evidence for it is trees cooling cities. And so this is a thermal image of New York City. And the big blue areas in there, one is the Hudson River. Thermal mass is a thing. But then that's Central Park, which has by far the highest tree cover in New York. And so this is one of those things that we can see across scales, and it has been really well quantified that trees cool cities. And also trees cool far more than other vegetation types. And so green roofs are great, but if we're talking about like literal pound for pound, where you're going to get more carbon storage benefits and cooling benefits, it's trees because they are gigantic. And so one thing, I'll get into it a bit more, but one thing to keep in mind is that most of these benefits of trees scale directly with their size. So whenever we're talking about, oh, what can I do to help make my city more climate friendly, climate resilient, protecting your big trees is kind of one of the first and most important things you can do, because it's going to take pushing a century for a tree to get that big. We can plant 1 billion small little trees, but until they start getting into the size where they're going to shade a house, the benefits aren't going to quite be there. And so that relates to kind of one of the reasons that the link between trees and urban cooling is so strong is that we really understand the mechanisms, the how for why this works. And so for trees, there's really kind of two aspects to that. One is shade. So it blocks solar radiation, it keeps the ground from heating up, it keeps your skin from heating up. And so there's the shade aspect to it. And that has a very localized impact on temperature. The other one that I'm really interested in is evapotranspiration, tree sweat. almost exactly kind of the same mechanism, or probably better analogous to a dog panting. So for trees to do their photosynthesis, energy from the sun, they have to exchange water for it. And it's really a lot of regional cooling power of trees comes from the evaporation of water outside of a tree. And so these are kind of those two mechanisms, and they really work hand in hand. And we need to think about this as we're moving into the future, because climate change is going to impact these. Shade maybe less so, but that evapotranspiration, that tree sweat bit, or if you've ever been in the Southwest, the swamp coolers. Ooh, somebody was talking about the greenhouses here, and you've got the misters that help with cleaning, or not cleaning, sorry, cooling. That's what trees do. And so this is an important process to understand because it's going to change in the future as temperature and the environment changes, but it also changes across space. And so this means that there is no one-size-fits-all solution or even goal you should have for something like canopy cover, because the impacts of how trees function are very different. It's the same kind of, well, unless you want to really nerd out about plant biology, it's the same general mechanisms for how these things work. But actually, if you have a single tree in Tucson, Arizona, it's going to provide you more cooling than a tree in Chicago. And that has to do with physics. It's a thing I never thought I'd have to use, and yet physics is a thing. So that arid environment, you get much more cooling from that evapotranspiration. You get many more benefits. However, it would be unfair. Bless those with the 30-30-30 tree canopy benchmark, 30% canopy in cities. That's not really a fair benchmark, because even though your trees are more efficient at cooling in Tucson's a desert. It does not naturally support a dense canopy. And so to be designing a solution, it really does need to be fit for that place. Whereas Chicago's even a weird place because we weren't entirely forested historically. And so really thinking about these natural contexts to set appropriate benchmarks. And one thing I will say is we've been doing some work evaluating cooling capacity of trees at a global scale and thinking about how much trees you would have to plant to completely offset the urban heat island effect using trees alone. On average, tree cover in cities would need to more than double. So trees can be an important part of the solution, but it's also going to need to be one part of a multi-pronged. So all of that work on decarbonization we talked about earlier is very important. All of those modifications to built environments is going to be very important as well. And so that's just setting goals based off of the world as it is today. We are here because climate change is a thing. Again, physics. And so as we're thinking about this, one of the challenges when we're talking about adaptation to climate change is that it's impacting communities and locations very differently. So if we look at patterns of warming by the end of the century, SSP 245, that's kind of the best case scenario in terms of warming and carbon emissions. 8.5 is that business as usual. It's all red because it's going to get warmer. There's a lot we don't know in science, but it's going to get warmer. But we have to be factoring this in as we do seed selections. What is locally adapted now may or may not be effective in the future. And then precipitation, obviously. And this is one of those challenging things where there's a lot of uncertainty around it, but there's also a lot of variability. And both of these factors, temperature and precipitation, fit into how well a tree cools the environment. Because as the temperature warms, trees need more water. I mean, a lot of y'all are plant people, even if not by degree. And so when it's hot, you have to water more. Hey, if it doesn't rain, you have to supplement it with additional water. And so what we've done is we've looked at how temperature is going to increase that evapotranspiration, that tree sweat, and how that compares to how much water you're getting. Here in Pittsburgh, people aren't too concerned about planting trees from a water sustainability perspective. But if you go out to Tucson, very much so, because the environment doesn't normally support that much. So what we have here is a map looking at water risk and kind of how we need to be thinking about is the current canopy suited to providing cooling in the future? So in that top panel, that's kind of the current balance. Yellow means low risk. You're using less water than you're getting in rain during the summer. Pretty coarse metric. In that kind of best case scenario in the middle pattern, you start to see red pop up in a lot of Europe and some parts of North America. And then by end of century, even places like Pittsburgh that currently receive quite a bit of precipitation, relative to Tucson. I'm going to pick on Tucson all day, apparently. It's really because of that heat-driven change. And what we have on the right is just kind of a metric of what we've been calling a precipitation deficit, broken down by biome. I won't get into it, but if you are looking at the right side, that means you have more rain than your trees and plants use. On the left side, it's different. And then, of course, one of the big trends here is that Europe, it's not a particularly hot place, Germany, or at least historically, but that double whammy of increasing temperatures and decreasing precipitation means that as we're thinking about nature-based solutions, we can't be thinking about the current conditions. We need to be thinking about the future. And also, what can we do to modify the environment to help mitigate some of that stress? Urban environments will amplify most aspects of climate change stress on plants for various reasons. And so hopefully this isn't the first time you've heard it, but when you're thinking about this, it's the right plant for the right place with the right care. And keeping in mind that for particularly something like trees, right care should mean decades in the future. So really thinking about what is your limiting factor as you're trying to design these nature-based solutions. Are you trying to put a tree in the city? If so, are you putting it in essentially a little concrete box that even I would have a hard time fitting in? Or are you willing to invest into things that can really help that root architecture? Different studies will give you different ranges for the average lifespan of an urban tree, but it's kind of the mid-range estimate is 20 years. Most trees should live for a couple hundred years. So making sure we're thinking about that and we're investing for that long term. And in terms of what some of those considerations are, species selection, absolutely critical. But there's actually a lot of robust information that needs to be done and needs to be generated. So that means that there's a lot of uncertainty into what the best plant is, and it's almost certainly not a single one. When we looked at tree species and drought resilience in the Chicago region, about half of the most commonly planted tree species in Chicago had conflicting recommendations on whether or not it was drought tolerant. And this comes from tree people. We looked at about over 250 tree species that are planted in the Chicago region. 20% of those had conflicting designations, and less than half of any of those tree species had actual quantitative information that would kind of pull it away from expert elicitation. And part of this is because what is drought tolerant in Chicago may not be drought tolerant in Pittsburgh because of this role of the environment in how that interacts with the biology of a plant. And this means that we are going to have to make decisions on imperfect information. And so that means that anytime we go into this, adaptive management and thinking ahead is going to be absolutely critical for uncertainty. I'm kind of guilty about one of the things I always rail on right now, which is often this is kind of the last part in any resiliency planning thing. Oh, create a monitoring plan and act on it. I am happy to talk people's ears off about that. But we need to have those plans in place now rather than saying, this is going to be the perfect tree for 20 years from now. Pittsburgh, Chicago, most of our large cities have seen it. Chicago, Dutch elm disease came through and wiped out a great tree. People say, okay, what's going to be the best tree we should plant to replace it? Well, it was ash. And those are two examples, but almost every region has had some version of that, and that is going to continue into the future. But I have no idea what the next species-specific pest that's going to decimate cities is. So we need to be planting a diversity as well as evaluating and trying different provenances to see, but we also need to be thinking ahead so that we get those seed sources in place, that we are able to kind of have these contingency plans. And we need to be thinking about that now because we are always going to have to make decisions with a huge amount of uncertainty. And I think I'm a nerd. Uncertainty is fun. if masochistic. And so that'd be a great thing to talk about, I think, in our breakout. But we have to be able to still take action now because we will never get rid of that future uncertainty. So that's what I got.